Welcome to Unit 4, Module 20, Earth Systems and Resources, Soil Formation, Erosion, Composition, and its Properties. In the previous module, we explored the layers of the Earth and how the rocky lithosphere moves as tectonic plates float above liquid magma. In this module, we explained how different types of rocks are formed in the lithosphere and how they are broken down by physical and chemical processes. These broken down rocks turn into the foundations of soil, which are formed as a mixture of minerals from rocks and organic matter from decomposing organisms, such as organic matter lies above the rocky soil, develop a distinctive layer that differs in their composition. Soils are a resource that can take tens of thousands of years to fully develop, yet human activities lead to the rapid erosion of soil, which degrades the ability to grow plants and retain an essential ecosystem function as the soil provides. So we're going to focus on the first part of primary succession. How does soil happen? Our learning goals today are describe the formation of igneous, sedimentary, and metamorphic rocks, identify the process that breaks down rocks, explain how soils are formed, describe what the cause of soil erosion, and identify properties that affect soil productivity. So, rocks form the basis of soil, and there are various sources of these rocks. There are three major types of rock formed by different combinations of heat and pressure. Magma is the original source of all rock, but there are all different methods that these rocks at the surface form from. So, are they directly from molten magma, by compression of sediments, by exposure to high temperatures and pressure? So, our first type of rock is the igneous rock that forms directly from the magma and can be either basalt or granite. So, there's only two types of rocks that it could be as far as classification. So, it'd be basalt rock or granite rock, and that is called igneous, directly formed from the magma. We have the basalt is the main type of rock in the oceanic, while granite is the main type of rock in the continental plates. As the granite breaks down onto the surface due to weathering, sand forms. So most of your sand on the beaches is going to be granite rock, sorry, not on the beaches, but just general sand in like sand mines or things like that, or quarries is going to be granite, whereas basalt is going to be from your oceans. Sedimentary rocks form from the sediments that are compressed by overlaying sediments over a long period of time. So that makes sense. Sedimentary rocks are formed from sediments and they're compressed together. And then finally, metamorphic rock is when sedimentary rock, igneous, or other metamorphic rocks are subject to high temperatures and pressures. So we start with igneous, we go to sedimentary, and then finally metamorphic. It's kind of the order that they form in as well. So here's some examples. If some of you are mineral people or you like to collect rocks, okay, we have some good examples of igneous, sedimentary, and metamorphic. Three different modes of rock formation are interlinked through the rock cycle. This governs the constant formation and alteration and destruction of rock materials resulting from tectonics, weathering, and erosion. So you can see we have igneous rock, which is cooled in crystallization of magma, and then through subduction, it might be melted and turned back into magma, or with some heat and pressure, turned into metamorphic rock. And we have sedimentary rock, which is caused by weathering and erosion and transport and compression. So this is rocks eroding away into smaller bits and then being compressed back together to form sedimentary rocks of sandstone or limestone. And then again, heat and pressure will form metamorphic rock. But all of three of these rocks have the ability to just be put back into magma and melted back. Okay, we're on our second standard now. Identify the process that breaks down rocks. At the Earth's surface, rocks are broken down by weathering and erosion. Weathering occurs when rock is exposed to air, water, chemical compounds, or biological agents. So we talked about how pioneer species have the ability to break down rocks, usually with acid, and that's what starts forming the soil. And we'll talk about the physical weathering is the mechanical breakdown of rocks and minerals, usually caused by water, wind, or variations in temperature, such as seasonal freeze and thaw cycles. So if water gets into any of the crevices or the holes in a rock and freezes, it's going to expand the rock. And then when it melts, that water will go away. Then the next season, that'll happen again, causing bigger cracks or holes in it to eventually where it's just going to split into be tiny rocks. Okay, we have chemical weathering is the breakdown of rocks and minerals by chemical reactions, the dissolving of chemical elements from rocks or both of these processes. So example of that would be like acid rain. So when rain or snow contains sulfuric or nitric acid, this is acid precipitation and acid rain, which can dissolve rocks and is responsible for the degrading of old statues, gravestones, and limestone and marble structures. So acid rain is a big problem with our global warming. We've got too many gases in our atmosphere that are being collected in the water vapor molecules and coming down and melting things. And then finally, erosion is a physical removal of rock fragments from landscapes or ecosystem. This can break down land. And many human practices, deforestation, overgrazing, unmanaged construction, and road building create accelerated rock erosions. Or Jeff City has a few quarries in it. So that would be an example of a human causing erosion, as well as deforestation would not help in overgrazing. Okay, we're on our third standard. Explain how soils are formed. So soils form as a result of parent material, climate, topography, organisms, and time. Soil has many functions that benefit organisms and the ecosystem. So soil acts as a primary filter of water, a medium for plant growth, a habitat for a variety of organisms, and breaks down organic material and recycles nutrients. Okay, so a medium for plant growth just means that is where plants grow. Plants don't need soil, but it gives them a place to root down and collect nutrients. But you could grow a plant without soil. It just gives it a nice place to grow. It filters water, so that happens through percolation. So as the water goes through the soil, it's going to catch some of those nasties that our plants don't need, as well as whenever it gets into our aquifers or our springs, then we can pull it up from there. Obviously, it's a habitat for worms and other bugs that go through and eat that organic material. And then it breaks down organic material and recycles the nutrients. So it's not actually the soil doing it, it's the things living in the soil, but that is a medium or a habitat for them. Soil takes hundreds or to thousands of years to form as a result of chemical and physical weathering of rocks with gradual accumulation of organic materials known as detritus. So soil takes a long time. So that primary succession stage is probably the slowest part is soil formation. And if certain facts are known, the specific properties of soil can be determined. So what was the parent material? Was it rocks? Was it dead organic material? What? The amount of time for formation, the climate, topography, and organisms. So we can figure out what these other things are based off of just looking at the soil. So here's kind of a time scale. So it says parent rock is weathered and fragmented. Fragments are moved upward. So that is very immature soil. It's just starting out. You can see mostly rock face here. Organic materials accumulate as plants and other organisms die. And then greater amounts of organic material are present in the soil. So you can see, again, how we start with mostly with rock. We get a little bit of soil, and then our soil gets deeper and more mature. Okay, it's the same thing as when you're going through primary succession. As a result of soil forming processes, soil develops characteristics horizons, which are horizontal layers with distinctive physical features such as color and texture. Fully formed soils consist of the O horizon, or is the organic horizon at surface, which organic detritus in various stages of decomposition, and the bottom layer composed of humus. A horizon, a top layer of soil comprised of organic material and minerals that have been mixed together, is called topsoil. E horizon is the zone of leaching and evaporation found in some acidic soils under the O horizon, or less often the A horizon. The B horizon, commonly known as subsoil, primary mineral material with little organic matter. So that's kind of your rocky layer, your gravel layer. And then the C horizon is the least weathered soil horizon, which is below the B horizon, similar to the parent material. And here's kind of what that looks like. So O is usually going to be up top, followed by A, E, B, and C. They don't really go in any alphabetical order necessarily. They're just labeled like that. So again, our C is our least weathered, so it's probably mostly rock. Our B is going to have a mix of minerals and metals and nutrients. E is going to be where things kind of leach down into. A is going to be topsoil, and B is where is our organic matter. And then notice that we're in meters, so less than a meter, or less than a tenth of a meter, less than a third of a meter, 1 meter down, and 1.3 meters. So not very deep takes to get to that rock layer. Okay, we're on our fourth standard now. Describe the causes of soil erosion. Soil erodes from contact against wind and water, as well as increases in human activity. Erosion occurs when topsoil is disturbed. Human activities such as plowing or deforestation lead to erosion by wind and water. Without the grounding system of roots from plants, the particles of topsoil can move quickly. When excess water from rainstorm washes over the topsoil, large amounts gets displaced. And a similar process occurs with wind, but extreme examples would be the occurrence of the Dust Bowl in the Great Plains in the 1930s. So, living in Missouri, that's part of your education is learning about the Dust Bowl. But essentially, we were not practicing good restorative agriculture processes. We weren't leaving enough roots in the soil, and so it was just blown away because there was nothing holding it back. So wind and water. So part of the issue that we live on the river here in Jeff City is when it floods, it takes a lot of our soil with it. And as we could see from here, a lot of our top nutrient or a lot of our nutrients is in these top meter of soil. And so when it floods, kind of taking some of that stuff with it, which means our soil's less nutritious for plants. And look how deep these roots grow into. So if we're cutting down trees, all these roots are dead and they're not holding the soil in. Whereas if we have our vegetation, it's holding the soil kind of in pat. Okay, so now we're on our fifth standard. So identify the properties that affect soil productivity. So soils have different physical, chemical, and biological properties that affect the productivity of it. Some soils are good for growing crops, while others are more suited for buildings. Productivity is affected by water holding capacity and nutrient availability. The physical properties of soil refer to size and weight. The main types of particles are sand, silt, and clay. The differences in size determine the air space of soil, which is porosity or porosity. Okay. So depending on what your soil is made up of can tell you what it's going to be good for. So if it's got a lot of air pockets in it, as well as it can hold water pretty well and nutrients pretty well, it's going to be good for growing things. If it can't do that, it's not going to be good for growing things. It might be better for putting buildings on, etc., etc. Scientists categorize the physical properties of soil by percentage of sand, silt, and clay contained in there. And so they use this graphic here or this chart here. So percentage of clay going up, percentage of silt going down, and percentage of sand. We're going to work with this later in this week. And depending on where you land up, it might be better suited for building buildings or planting or having a field put on you for a football team, et cetera, et cetera. Using each side of the triangle to determine the soil's level of porosity. So how porous is it? Okay, and like I said, we're going to look at this later this week. Water holding capacity is the amount of water a soil can hold against the draining forces of gravity. So sometimes you'll look at a bag of soil and it says holds water well or drains well. Depending on what type of plant you're growing in there, you might want one that holds water well if your plants like to have moist soil, or if you're growing things like succulents, you probably want well draining water because they don't like having wet roots. Permeability is the ability to water to move through the soil. Okay, so is that a well draining soil? It'd probably be pretty permeable. An increase in percentage of sand would increase the permeability, while an increase in percentage of clay would decrease the permeability. Okay, so that makes sense. So Missouri soil has a lot of clay in it, and it holds water pretty well, whereas soil in places like Arizona is probably going to be more sandy and does not hold water very well. Because of the clay's ability to be tightly packed, it's useful in landfills to prevent contamination of groundwater. So that's also the reason why we use clay to make objects like coffee mugs and things like that, as it sticks together really well, and it's hard for things to get through it like water. It's going to hold water really well. Usually at the bottom of your lakes and ponds, if they don't have a rock bottom, they're going to have a clay bottom because that prevents the water from seeping through, and it's going to hold the water in a lot better as opposed to letting it percolate through the soil and becoming groundwater. So like I said, most of your lakes and ponds are going to have like a muddy clay consistency to hold that water in. Okay, we're going to do something similar to this lab this week. So soil, water, holding capacity, and permeability. So water, silt, and clay. So at time 0, it's going to be here. For just sand, you're going to lose a lot of water. For silt, you're going to lose water less efficiently. And then at 100 years, your clay is going to be there. So like I'm saying, it's good for ponds and things like that. Chemical properties also play an important role in how soil functions. Clay particles are able to attract positively charged mineral ions known as cations. The ability of particular soil to absorb and release cations is known as a cation exchange capacity, or CEC is what you might see in your textbooks. Some nutrients and ions commonly identified in soils are nitrogen, phosphorus, potassium, and calcium. Another aspect to consider in soil chemistry is the base saturation, which is the proportion of soil bases to soil acids. Too many acids can be harmful to plant nutrition. So if you notice, you need these two to build DNA, and you need nitrogen to build proteins. And so that's good that we have that there for our plants. And potassium, calcium are things that they will also absorb. And depending on what type of plant you have, will affect their growth, such as bark or fruit, etc. Or like your vegetables, like potatoes, have a lot of potassium. They have to get it from somewhere, and they're getting it from the soil. And a lot of your root vegetables do as well. Okay, biological properties of soil are determined by 3 main groups: fungus, bacteria, and protozoa. Large organisms like earthworms, moles, and rats help mix the soil and aerate it. And snails and slugs consume plant roots, and many other organisms consume dead plant material and tissues, which contribute to the recycling nutrients of, and these are called detritivores. So if they eat dead material and put it back into the soil, we're calling them detritivores. And that those are going to affect the soil productivity. So if you don't have a lot of micro communities living in your soil, it's probably not going to be very nutritious. So you want to encourage things like bacteria and fungus and earthworms and moles and snails and slugs. So if you want to have a healthy garden, a lot of people get rid of their snails and slugs because they eat some of the plants, but it's going to be better for your soil long term and restorative agricultural practices. So that's kind of a good image right there. Is your snails and slugs, again, are going to be on the top eating some of your plants, which you might lose some of them in a garden, but eventually they're going to go back into the soil, and it's going to be better for your soil life long term. You guys know that worms and moles are going to move through your soil and make it more aerated and eating that dead material. And then bacteria are doing your nitrification processes and cellular respiration, putting a lot of that material back into the soil, which your plants need. Okay, and then as always, we're going to answer the questions that are the beginning of your review right here. So the first one is how igneous, sedimentary, and metamorphic rocks are formed. Igneous rocks form directly from magma. Sedimentary rocks from sediments such as mud, sand, and gravels are compressed by overlaying sediments. Metamorphic rocks form when sedimentary rock, igneous rock, and other metamorphic rocks are subject to high heat and pressures. Number 2, what are some processes that break down rocks? Rocks are broken down by physical weathering, which can be caused by water, wind, or variations in temperature. It can also be caused by the activity of organisms. Rocks are also broken down by chemical weathering, such as reaction caused by weak acids and the dissolving of minerals. Standard number 3, how are soils formed? Soil formation begins with the breakdown of rocks that serve as parent material. It is also influenced by the climate of area because climate determines the range of temperature and precipitation that affect weathering and leaching of nutrients. Additional factors include topography, organisms, and the amount of time that passes from these processes to occur. Soil horizons are horizontal layers with distinct physical features, such as color and texture. Standard number 4, what causes soil erosion? While erosion occurs naturally, human activities can dramatically increase the amount of erosion. Water causes erosion when plants have been removed from the area, leaving no roots to hold soil particles together. Wind can cause erosion, particularly when the land has been plowed, and droughts prevent many plants from growing and holding the plant soils. Then finally, number 5, what properties affect soil productivity? Physical, chemical, and biological properties affect the productivity of soils. Soils with more clay particles have greater water holding capacity and higher nutrient capacity. However, having too much clay can make it hard for plants to extract the water and nutrients from the soil. And that is your Module 20. Let me know if you have any questions.